Welcome to the Deep Dive. Today we are boarding, well, a cosmic mystery that has really ripped through the scientific community lately.
It really has.
We're looking at a space visitor that's, frankly, rewriting textbooks.
Mm-hmm.
And at the same time, fueling probably the most explosive and, controversial debate in modern astronomy.
We're talking about 3I Atlas. It was discovered mid-2025. And this object, it's only the third confirmed interstellar visitor we've ever actually tracked moving through our solar system.
Right, after Oumuamua and Borisov.
Exactly.
Sure.
Following Oumuamua, the cigar-shaped one, and then Borisov, which looked much more like a typical comet. But if those first two seemed a bit strange,
Yeah, they definitely did.
3I Atlas is just operating on a whole different scale. The complexity, it makes it a true outlier among outliers.
Absolutely. This isn't just any visitor. It's like an ancient ghost moving at, terrifying speed. The data shows it's simultaneously the fastest, the oldest, and the most mysterious interloper we've seen yet.
Mm-hmm.
I mean, just consider this for a second. Its estimated age is up to 11 billion years.
11 billion.
Yeah, that is nearly 3 times older than our own solar system, which is about 4 billion years old.
Yeah.
The genuine galactic senior citizen,
Definitely puts things in perspective.
And it's hurtling through space at roughly 200,000 kilometers per hour. That locks in its title as the fastest comet ever observed.
And those extreme stats alone would make it a huge phenomenon, right? Worthy of study for decades. But what's really elevated 3I Atlas into this global event is, a pretty prominent scientific hypothesis.
Right.
The central mystery we're really unpacking today is critical. Is 3I Atlas just a hyper-rare, incredibly peculiar natural comet, maybe formed under conditions we barely understand?
That's the other option.
Or, as some, influential scientists are hypothesizing, is it a sophisticated, maybe long-dormant technological artifact? Potentially one masked as a natural object, and maybe, just maybe, even a hostile one.
That's the core question, isn't it? And the implications are just profound. So our mission today is to take all this data you mentioned, the orbital stats, the bizarre chemistry, the kinetic anomalies, and really help you, the listener, understand these two competing explanations.
Yeah, just try to make sense of it all.
We need to get why this one object is forcing astronomers to seriously consider concepts that, honestly, usually belong in science fiction.
Well, before we dive straight into the hard data, I think we have to set the stage a bit. Address the philosophical backdrop for this whole debate, because this object, whether it's just rock or some kind of relic, it taps directly into that great question of existence. Are we alone?
Which, naturally brings us straight to the Fermi Paradox. It's an old puzzle, but still incredibly profound.
Right. Back in, 1950? Physicist Enrico Fermi, legend has it, was just having a casual conversation about flying saucers, interstellar travel.
Lunchtime chat, basically.
Yeah, exactly.
Yeah.
And he stopped, apparently did one of those quick back-of-the-envelope calculations in his head, the kind he was famous for.
The Fermi calculation.
Right. And then he just asked, simply but powerfully, where are all the extraterrestrials?
It's such a great question because the logic seems so sound.
It is. That quick mental exercise, it leads to ideas similar to the Drake equation later on. The basic logic is you look at the billions upon billions of stars just in our Milky Way. Then consider the percentage of those likely to have planets. Then factor in the sheer amount of time available for evolution. We're talking cosmic timescales here, billions of years.
Yeah, deep time.
Then statistically, the galaxy should have been colonized. It should be teeming with advanced, detectable civilizations. And not just recently, but long, long ago.
The numbers involved are just staggering. Even if you assume the probability of intelligent life arising on any one planet is really, really low.
Vanishingly small, even.
Right. The sheer number of opportunities, the number of planets over billions of years, means that highly advanced technological civilizations shouldn't just be common. They should be, pervasive. They're signals, they're artifacts. They should be everywhere.
And yet, silence. So the paradox is born, this staggering probability of their existence versus the profound, observable silence of the cosmos. Where is everybody?
Yeah. It's a silence that's led to a lot of proposed solutions, hasn't it?
Yeah, absolutely. Everything from the idea of the great filter, some kind of theoretical barrier that wipes out most life before it gets truly technological.
Like climate change or nuclear war or something we haven't even thought of yet.
Exactly. Or maybe the idea that advanced life is just fundamentally rarer than our calculations assume. Maybe the jump is harder than we think. But the most Well, chilling solution, and the one that's really relevant to this 3ILS debate, is the dark forest hypothesis.
The dark forest. That suggests the universe isn't exactly a friendly neighborhood block party.
Not at all. It's a vast, dangerous wilderness. It basically postulates that advanced civilizations aren't necessarily peaceful or cooperative.
No Starfleet Federation, then.
Probably not, according to this theory. Instead, they might be predatory, expansionist, recognizing that broadcasting your existence, sending out signals saying, here I am, is basically just inviting destruction from someone older, bigger, more advanced.
It becomes a game of ultimate cosmic survival. Every other civilization is a potential threat until proven otherwise. And proving otherwise might be too late.
Exactly. It's the ultimate zero-sum game. You mentioned that analogy earlier, the cheetah and the gazelle. I think that really captures the motivation.
Yeah, explain that again.
Well, a cheetah hunting a gazelle doesn't roar, doesn't announce its presence. It stays absolutely silent, hidden, uses camouflage, approaches slowly, until it can strike with overwhelming surprise and minimal risk to itself.
Okay.
The dark forest idea implies that the profound, really unsettling silence of the universe isn't a sign that nobody's out there. It's a sign that everyone who is out there is being deliberately, deathly silent, hiding, to avoid attracting the attention of a predator. So, if 3I Atlas turns out to be a controlled object, maybe one moving on some kind of intercept course, well then that dark forest theory suddenly shifts from a creepy philosophical idea to a very urgent, very real strategic concern.
That definitely sets the stage. The stakes couldn't be higher. Okay, let's move past the philosophy then and get into the actual physical data. The facts about 3I Atlas, starting with its discovery and these anomalies in its trajectory, the statistical case, as some put it, for intelligent design.
Right. So the object was first spotted on June 1st, 2025. The ATLS system picked it up. That's the Asteroid Terrestrial Impact Last Alert System. Basically robotic telescopes scanning the sky for things heading our way.
And they knew pretty quickly it wasn't one of ours.
Immediately. They confirmed it was on a hyperbolic trajectory. That just means its speed is too high for the sun's gravity to capture it. It came from interstellar space, and it's heading back out eventually. It's just passing through.
And the size estimates.
Yeah.
They're pretty daunting, right? We remember Oumuamua was relatively small, maybe a few hundred meters long.
Yeah. Oumuamua was tiny in comparison. Early estimates for 3ILS put its nucleus somewhere between maybe 300 meters at the very small end, up to potentially over 5 kilometers. That translates to maybe 33 billion tons of mass. It's significant.
Massive.
And that initial size ambiguity actually created the first statistical problem. Because if it were just a solid, non-active asteroid, like a big rock, the size of 5 or 6 kilometers coming from another star system, that would be statistically almost impossible. We expect our solar system to have chucked out trillions of small bodies over its history, but the chance of finding a non-cometary, kilometer-scale rock from another star, truly astronomical, vanishingly small.
But later observations cleared that up. It is a comet.
Yes. Later observations, especially with powerful instruments like the James Webb Space Telescope, confirmed it is active. It has a coma, that cloud of gas and dust. So it's a comet, which avoids the impossible asteroid problem, but the trajectory itself remained deeply suspicious.
Okay, let's run through these orbital mechanics then. The things that have scientists really scratching their heads. These are the core arguments suggesting its path wasn't just random chance. What's anomaly number one?
The first big one is its ecliptic alignment and retrograde motion. Okay, so the ecliptic, that's basically the flat plane where all the major planets in our solar system orbit the sun. Earth, Mars, Jupiter, they're all roughly in this plane.
Like cars on a racetrack, more or less.
Pretty much. And 3ILS, its trajectory is highly aligned with this plane. It's only tilted about 5 degrees away from it.
Wait a minute. If a comet gets randomly booted out of another star system, zipping through the galaxy for billions of years, wouldn't it be just as likely to come screaming in from, like, the North Pole or the South Pole of our solar system, perpendicular to the planets?
Exactly. If its entry were truly random, dictated by galactic drift, you'd expect it to arrive from pretty much any direction in 3D space. The odds are it would come in at a high inclination, a steep angle relative to our planetary plane.
So the fact that it's almost perfectly in that plane, what are the odds?
The calculated probability of it aligning this closely within 5 degrees purely by chance, it's incredibly low, around 0.2%. That's like 1 in 500.
Okay, 1 in 500. Still possible, maybe. But why is that specific alignment interesting from a, let's say, a design perspective, if you wanted to visit?
Well, think about it. If you were designing an interstellar probe, maybe a reconnaissance mission, that trajectory is optimal. It minimizes the energy, the fuel you'd need to access and observe multiple planets in our system.
Because you're already in the same line as them.
Precisely. If you come in at a steep angle, you have to burn massive amounts of propellant to change your inclination, to flatten your orbit out and visit Mars, then Venus, then Jupiter. This object arrived in the perfect express lane to tour the neighborhood with minimal effort.
Okay, that's point one, suspicious alignment. And that seems even more intentional when you pair it with the second anomaly, the unlikely close planetary passes. It's not just in the right lane, it seems to be aiming for specific exits.
This is where the statistics get genuinely, well, striking. 3ILS isn't just cruising through the solar system vaguely near the planets. It's slated to pass remarkably close to three major bodies in pretty rapid succession.
Which ones?
Mars first, a pass at only 0.19 astronomical units, AU. That's scheduled for October 3rd, 2025. Then Venus, a bit further out at 0.65 AU on November 3rd, 2025. And then a big one, Jupiter, at just 0.36 AU on March 16th, 2026.
Okay, put 0.19 AU for the Mars flyby into perspective. How close is that?
That's about 28 million kilometers, which sounds like a lot, but in cosmic terms, especially for gravitational influence, that's a significant interaction. It's not just a distant wave hello, it's close enough for detailed observation or even potential gravitational effects.
And the argument is that the sequence of these three specific close passes happening just by random chance, that's what researchers calculate, is almost impossible.
That's exactly the point. When you calculate the overall probability for all three of these major gravitational encounters, Mars, then Venus, then Jupiter, lining up so neatly, just by pure random chance as the object flies through, the number becomes astonishingly low, less than 0.005%.
Wow, 0.0005%. That's tiny.
It's incredibly tiny. The trajectory seems to perfectly thread the needle past these three major bodies. The implication, from the skeptical viewpoint, is profound. Maybe this path wasn't just the result of random galactic drift. Maybe it was selected, targeted for maximum systemic interaction, a planetary tour.
Okay, a highly suspicious alignment combined with a statistically near impossible series of close flybys. Let's connect that trajectory now to the idea of a potential hostile or at least secretive agenda. This brings us to the third critical point you mentioned, the clandestine maneuver window. This is where the timing seems just perfect for a surprise.
This point is really central if you're considering the dark forest angle. The object reaches its closest point to the sun, that's called perihelion, on October 29th, 2025.
Okay, end of October.
Now, what's perfectly synchronized with that critical date, the point of its maximum speed and solar proximity, its trajectory places it directly behind the sun, completely obscured from Earth's view. We won't be able to see it for a period around then.
Hidden from view right when it's closest to the sun. Why is perihelion the critical time for a potential maneuver? Why not just change course somewhere else, further out?
It comes down to physics, specifically something called the Oberth effect.
Right, you mentioned that. Explain it again.
Okay, the Oberth effect basically says that when you apply thrust to a spacecraft like firing a rocket engine, the resulting change in your kinetic energy, your speed, is maximized when you are already traveling at your highest velocity.
So you get more bang for your buck when you're already moving fast.
Exactly. And where is 3ILS moving fastest? Right near the sun, because the sun's immense gravity is pulling it in and accelerating it. So perihelion is the optimal point for any spacecraft to conduct a high-thrust maneuver, like braking, to drastically change its trajectory using the minimum amount of fuel.
Let's use that baseball analogy again.
Sure, if you're standing still and throw a baseball, it goes a certain distance. But if you throw that same baseball with the same arm strength while you're riding on the back of a speeding freight train...
It goes much further.
Right, because the energy you impart gets added to the huge energy the train already possesses. It's similar near the sun. The object already has enormous kinetic energy from falling towards the sun. So a relatively small application of braking thrust, what we'd call a reverse solar Oberth maneuver, right at that moment, can have a huge effect. It can drastically change its path with far less fuel than doing it out in deep space.
So if you were an incoming vessel, maybe disguised as a comet, and you wanted to switch from your current path, this hyperbolic escape trajectory, to maybe a bound elliptical orbit, staying in our solar system, or perhaps even shift onto an intercept course with a specific planet, like Earth.
You would absolutely execute that major braking maneuver right at perihelion when you're moving fastest and closest to the sun.
If you had malicious intent or just wanted to stay hidden like in the dark forest.
You do it precisely when you're hidden from view behind the sun. The obscuration allows this potentially massive maneuver to happen in secret. We wouldn't see the engine fire, we wouldn't detect the immediate change in path.
So it could emerge from behind the sun on a completely different trajectory than expected.
Yeah.
Maybe heading towards Earth for arrival in, say, late November or early December.
That's the chilling possibility raised by the hypothesis. A surprise arrival, perfectly aligning with the strategy of a silent, potentially predatory civilization. Maximum efficiency, maximum stealth.
Wow, okay. And there's a final piece to this trajectory puzzle, isn't there? It ties into why we didn't spot this thing much sooner. Why any chance of sending our own probe to intercept it was already gone.
Right. Where did it come from? The object arrived from the direction of the galactic center?
The center of the Milky Way.
Yes. Now, visually, that region of the sky is incredibly dense. Billions of stars, huge clouds of gas and dust. It's a very bright and cluttered background.
Making it harder to spot a faint incoming object against all that noise.
Significantly harder. Much more complex than if it had come from, say, above or below the plane of the galaxy, from the galactic poles where the background is darker and simpler. This specific arrival direction significantly delayed and complicated its initial detection from Earth-based surveys like ATLS.
So by the time we actually found it, June 1st, 2025, any possibility of launching our own mission, maybe to get a closer look or even hypothetically defend against it, that window had long closed.
Completely closed. Researchers did the math. The optimal launch window for any kind of human intercept mission, and we're talking something needing extremely high energy propulsion, like advanced nuclear rockets, not current tech.
Right.
That window was likely over a year before we even discovered it, probably around mid-2024. So the arrival path wasn't just efficient for planetary flybys. It was also perfectly timed and oriented to prevent any defensive or even reconnaissance response from us.
So let's recap the trajectory anomalies. We have 1, extreme alignment with the planetary plane, 0.2% probability. 2, unlikely close passes of Mars, Venus, and Jupiter, less than 0.005% probability. 3, perihelion timed perfectly with solar occultation, ideal for a hidden O-berth maneuver. And 4, arrival from the galactic center, delaying detection until an intercept was impossible.
Taken together, that sequence of anomalies paints a picture, for some, of a non-random, targeted, and very deliberately timed path.
Okay. If we only look at the trajectory, the statistical argument for design over random chance seems incredibly compelling. But as you pointed out, science has to default to natural explanations first, however weird. So let's move into section 2, the physical and chemical signatures. What did our big telescopes actually see when they looked closely? Did the physical evidence reduce the mystery, or did it just deepen it?
Oh, it deepened it considerably. As we mentioned, those initial observations were a bit confused. When the survey telescopes didn't immediately detect a big, obvious cloud of gas, significant outgassing.
We thought it might be an asteroid.
Right, it got provisionally categorized as maybe a massive 5 or 6 kilometer asteroid. But as we discussed, that size for an interstellar asteroid is statistically problematic in itself. Anyway, that classification was quickly overturned.
By Webb and Hubble?
Primarily, yes. Observations using the James Webb Space Telescope, JWST, and also Hubble confirm that 3I Atlas is active. It definitely has a coma, that fuzzy atmosphere of gas and dust. So, okay, it is a comet. We move from the statistically impossible giant asteroid scenario into the realm of an extremely unusual, very old comet.
And the spectroscopic DNA, what Webb could tell us about its chemical makeup by analyzing the light from its coma, that's where things get really bizarre, right?
Yeah.
Especially compared to the comets we know in our own solar system.
It's fundamentally bizarre. It basically violates our standard expectations for comets. Comets that formed out here in our solar system are typically very rich in water ice. That's their main component. When they get close to the sun, that water ice turns directly into gas supplements and creates the characteristic coma and tail.
Makes sense. So what about 3I Atlas?
It's almost dry. Spectroscopic analysis of its gas plume shows it contains only about 4% water by mass.
Only 4% water. That's incredibly low for a comet.
Yeah.
So what is it made of then? What's creating the gas plume we see?
It's overwhelmingly dominated by simple carbon molecules, primarily carbon dioxide CO2, estimated at a whopping 87% of the gas.
87% CO2. Dry ice, basically.
Pretty much a giant, ancient block of cosmic dry ice, and then another 9% is carbon monoxide, CO. So you add that up, CO2 and CO make up about 96% of the observed gas. Water is just a tiny trace component.
That CO2 to water ratio must be completely off the charts compared to normal comets.
It is. It's about 16 times higher than what we'd expect for a standard comet orbiting at that same distance from the Sun. Only one other known object, a very peculiar comet called C2016 R2, has shown anything remotely similar, and even that wasn't quite this extreme.
Okay, that's a massive deviation. If it's so incredibly rich in CO2 and CO, what's the proposed natural explanation from astronomers? How could a comet form like that?
Well, the consensus thinking is leaning towards its formation environment. The idea is that the nucleus must have formed in an extremely cold part of its original protoplanetary disk, way back when its home star system was forming. Colder than where our comets formed. Specifically, out near or beyond the CO2 ice line, the distance from the star where CO2 freezes solid.
So maybe conditions near the galactic center, where it seems to have come from, were just fundamentally different or much colder, allowing these weird compositions to form.
That's the leading natural hypothesis, that its building blocks were dominated by frozen CO2 and CO, not water ice. Alternatively, some have suggested maybe there's some unknown geological process inside the comet, trapping the water ice deep within the core, preventing it from sublimating easily. But that feels a bit more like hand-waving. The formation environment explanation seems more plausible, if still exotic.
So it's either a product of some extreme alien stellar nursery chemistry, or it's something else entirely, especially when we look at the other things detected in its gas plumes, the heavy metals, the potential industrial signatures.
This is perhaps one of the trickiest anomalies to explain away naturally. The spectroscopic analysis didn't just find CO2 and CO, it also confirmed a surprisingly high proportion of the metal nickel relative to iron in the gas plume.
Nickel. Okay, metals aren't totally unexpected in comets, are they? From
Yeah.
dust.
Trace amounts of metals in the dust, no. But the ratio was a bit unusual. But the critical finding, the real bombshell, was definitive evidence of a specific compound. Nickel tetracarbonyl. Nice name for.
Nickel tetracarbonyl. Okay, that sounds specific. Not just elemental nickel.
Exactly. It sounds highly processed because, well, it usually is. This compound is extremely unusual to find just floating around in space. On Earth, we know it almost exclusively because of its use in industrial processes.
Like what?
Specifically, the Mond process. It's a well-established industrial technique used for refining nickel metal to a very high purity. It involves reacting nickel with carbon monoxide under specific conditions.
And finding that specific industrial compound outgassing from a supposedly natural comet? That's hard to explain.
Very hard. The natural formation of nickel tetracarbonyl requires a pretty rare combination of conditions: high heat, high pressure, high concentration of both nickel and carbon monoxide, which seems almost impossible to imagine existing naturally on the cold, vacuum-exposed surface of a comet nucleus billions of years old.
So why would the proponents of the artificial hypothesis flag this as an industrial signature? What does it suggest to them?
It suggests material processing. If, hypothetically, you were building a massive kilometer-scale metallic structure, maybe an engine or a habitat or shielding, you might use industrial refining processes like the Mond process that involve nickel tetracarbonyl. Finding this compound coming off the object could, they argue, suggest the outgassing of leftover waste products or maybe even structural components slowly degrading, rather than just the natural elemental mix of the comet's birthplace.
So while the mainstream insists there must be some exotic, undiscovered natural chemical pathway to create this,
the fact remains that the most familiar context for this specific molecule is Earth-based industry. It's a chemical signature we strongly associate with technology.
okay, another weird check mark in the anomaly column. Then there's the way light reflects off it, this bizarre optical property, the extreme polarization.
Yeah, how light behaves when it bounces off the object or its dust is also unique. Polarimetry observations revealed an extreme negative polarization. Polarization basically measures how the light waves are aligned after they reflect off a surface. Most solar system bodies show some polarization, but 3I Atlas showed a negative polarization signature that is, as far as we know, entirely unique.
Nothing else like it, not even the other interstellar object, Borisov.
Nope. Borisov, despite being interstellar, showed polarization typical of comets in our own solar system. 3I Atlas's signature is off the charts different. It has this very specific, very narrow, and extremely deep negative polarization curve.
And what does that imply about the surface or maybe the dust particles in the coma?
It's hard to say for sure. It could indicate an entirely new, unknown type of material or dust composition that interacts with light in this strange way, something we've simply never classified before. Or perhaps it suggests a highly structured surface, maybe something microtextured or made of specific materials, that interacts with light in a way that suggests artificial design rather than the chaotic jumble of a natural comet surface. It forces us, at minimum, to revise our entire catalog of expected cometary light scattering properties.
Okay, so its basic chemistry and even how it reflects light are deeply weird. But beyond these static properties, the behavior of 3I Atlas as it got closer to the sun was also kinetically anomalous, right? Let's talk about the Antikyla. That sounds backwards.
It is backwards.
Yeah.
During July and August of 2025, instruments briefly detected a temporary jet of material pointing towards the sun, instead of the expected direction, which is always away from the sun due to solar wind and radiation pressure pushing the gas and dust out.
Yeah, comet tails point away from the sun, always. Why would material jet towards the sun?
Well, natural explanations do exist, but they're usually quite complex. They often involve things like the specific rotation axis of the comet's nucleus combined with maybe chunks breaking off and being thrown forward in the orbit before the solar radiation pressure has time to push them back. It can happen, but it's usually transient and requires specific geometry.
But to the proponents of the technology hypothesis.
To them, this brief reverse jet looked less like a random outburst and more like potentially controlled venting, maybe for attitude control or stabilization or perhaps even a tiny course correction before the object settled back into producing a more conventional cometary tail later on. It adds to the picture of unpredictable, maybe non-natural activity.
And the object's appearance also changed dramatically around then too, didn't it? Both in brightness and its color.
It absolutely did. As it raced towards perihelion, the object brightened much, much faster than a typical comet would at that distance, about 7 times faster, according to the reports.
7 times faster. What does that suggest?
It suggests a really intense, sudden surge in activity. Something caused it to start outgassing or reflecting light much more efficiently, very rapidly. And complementing this rapid brightening, it started to display an intensely blue color.
Blue. Aren't comets usually yellowish or reddish?
Almost always, yeah. That typical color comes from sunlight scattering off larger dust particles in the coma. This intense blue hue seen in 3I Atlas was striking reportedly bluer than the sun itself. That usually implies scattering by extremely fine particles, maybe submicron-sized dust, or possibly it's related to the specific gases being ionized, like the huge amounts of CO and CO2. Whatever the cause, it was another sign of extreme, somewhat unpredictable, energetic behavior that didn't fit the standard comet profile.
Okay, this list is getting long. Finally, we have to revisit that idea of artificial propulsion, but this time maybe with more direct evidence, the detection of non-gravitational acceleration. This seems to move beyond just statistical suggestions into actual observed non-Newtonian motion.
Right. Careful measurements of its orbit confirmed a slight but definitely measurable non-gravitational acceleration. This means something other than just the sun's gravity and the much smaller poles of the planets is influencing its path. It's being pushed, however gently, by some other force.
Like a continuous rocket effect.
Exactly. It's mimicking a very low-thrust engine. Now, this phenomenon was famously observed with Oumuamua as well, and it caused huge debate then, too. The default explanation is always natural outgassing.
The comet releasing gas acts like a rocket, pushing it slightly off course. Makes sense. But what's the problem with that explanation for 3I Atlas?
The problem is the scale. To produce the magnitude of non-gravitational acceleration that was measured, standard physics calculations imply a truly massive loss of material from the comet. Like up to 15% of its entire estimated mass, possibly over 5 billion tons, would need to be expelled relatively quickly through outgassing to create that push.
15% of its mass. 5 billion tons.
Yeah.
That's a colossal amount of gas and dust.
It's enormous, and here's the core contradiction. Scientists have not observed the expected massive debris cloud or the incredibly bright, dense coma that should accompany that level of outgassing. If it were naturally shedding 5 billion tons of material, it should look incredibly active, maybe even visibly disintegrating, but it doesn't.
So we have the observed acceleration.
Yeah.
But without the observed exhaust plume, needed to explain it naturally.
Precisely. Acceleration without the visible fuel source. It's a profound contradiction. If the gas and dust aren't there in the expected volumes, where's the acceleration coming from?
And that, of course, strongly fuels the technological hypothesis again.
It does. It suggests an object that can accelerate non-gravitationally, but maybe without the messy, visible consequences of a natural body rapidly losing mass. It hints, perhaps, at a more focused, efficient, and maybe hidden thrust mechanism, something not relying on just sublimating ice.
Okay. And just when you think the data couldn't possibly get any stranger, there's one last bizarre coincidence linking it to a famous unsolved mystery from decades ago.
Yeah. The final anomaly, let's call it anomaly number 8, brings radio astronomy history into it. The incoming trajectory of 3I Atlas, where it appeared to come from on the sky, it aligns within about 9 degrees of the calculated origin point of the famous 1977 WOW-W signal.
The WLW signal, detected by the Big Ear Radio Telescope in Ohio, right? That super strong narrowband signal that lasted 72 seconds and then vanished.
That's the one. It hit frequencies near the hydrogen line, looked exactly like what some scientists expected an artificial beacon might look like. It has never, ever been detected again, despite many searches of that same patch of sky. It remains probably the single strongest candidate we've ever had for a potential extraterrestrial radio transmission.
And 3I Atlas just happens to arrive from roughly the same direction in space, all these decades later.
Roughly, yes. Within 9 degrees. Now, is it just a coincidence? Almost certainly. Correlation doesn't equal causation. But given all the other weirdness surrounding 3I Atlas, the simultaneous arrival of the spectacularly unusual physical object from the same general area as that famously unexplained radio signal, well, it's certainly a stunning coincidence, isn't it? Adds another layer of intrigue, even if it's likely just that a coincidence.
So let's pull back for a second. We have this highly improbable trajectory. We have chemical signatures like the nickel tetracarbonyl or the weird CO2-water ratio. We have unique physical properties like the blue color and the polarization. We have kinetic anomalies like the anticola and the unexplained non-gravitational acceleration. And a weird historical coincidence with the WOW signal. It's quite a list. Now we have to ask the big question. How does the scientific establishment weigh all these extraordinary facts against the fundamental assumptions of astrophysics? Let's move into section 3. The scientific reckoning, probability versus speculation. How does the mainstream view hold up?
Well, as we touched on, the overwhelming majority of the scientific community maintains that 3I Atlas, despite all its weirdness, is a natural object. An extremely unusual one, yes, maybe one that pushes our models to the limit, but natural nonetheless.
And the core argument for that is simply sticking to the scientific method.
Pretty much. The argument is that maintaining the default assumption of natural origin is the bedrock of science. When you encounter an outlier, something that doesn't fit, the first step is always to try and expand or revise your existing models, our understanding of comet formation, galactic chemistry, etc., not to immediately jump to inventing entirely new categories of explanation, like alien technology.
Okay, but what about those trajectory statistics we discussed? Less than 0.005% chance of those 3 planetary flybys happening randomly. How does the consensus view refute numbers that seem so incredibly low?
They counter it with a very powerful argument, the argument of relative abundance. Basically, you have to contrast the theoretical number of alien spacecraft zipping around the galaxy with the sheer, undeniable population of natural debris that we know exists.
Okay, run the numbers on that.
Let's just look at our own solar system. Current models estimate that over its 4.5 billion year history, our system has ejected somewhere between trillions, that's 10, 12, and possibly hundreds of trillions, 10, 14 of comets and asteroids out into interstellar space.
Trillions just from us. Wow.
Exactly. Now extrapolate that across the hundreds of billions of star systems in the entire Milky Way galaxy over billions of years. The interstellar medium must be absolutely flooded with trillions upon trillions upon trillions of natural rocks, ice balls, and dust particles ejected from other systems.
So the odds of encountering one of those
are vastly, vastly higher than encountering a kilometer-sized alien spacecraft, something deliberately manufactured and deployed. The probability difference is likely astronomical, maybe trillions to 1 or even more, in favor of any random interstellar object being natural debris versus artificial technology. Our galaxy is overwhelmingly biased towards producing and ejecting rocks and ice, not sophisticated kilometer-scale vessels.
This is where that famous statistical analogy comes in, right? The cat on the terrace.
Yeah, exactly. It's a classic illustration of Bayesian reasoning, basically. If you're inside your house and you hear a meow sound coming from your terrace, what's the most likely explanation?
It's a cat.
Right. Is it possible that it's a highly advanced alien entity disguised as a cat, perfectly mimicking its sound? Well, you can't strictly disprove that hypothesis, but given the overwhelming relative abundance of actual cats in your neighborhood compared to the presumed rarity of cat-disguised aliens, the only rational, scientifically sensible conclusion is that it's just a cat.
And the consensus applies that same logic to 3I Atlas.
Pretty much. It might be the weirdest, most exotic cat we've ever seen, but statistically, given the sheer number of natural cats, interstellar objects, expected out there, the default assumption has to be that it's a natural object, however strange its meow sounds.
That makes a lot of logical sense, just based on sheer numbers. But the scientist who is pushing the alien hypothesis, he argues that this kind of thinking is exactly where we risk missing something truly revolutionary. He emphasizes being open-minded. But isn't there a statistical danger in taking all those unique traits we listed, the blue color, the nickel compound, the specific alignment, and then calculating their combined low probability to try and prove it must be designed?
That is precisely the core statistical rebuttal offered by many of his peers. It highlights the danger of what's called posterior selection bias.
Posterior selection bias. Break that down.
It's a really crucial concept in statistics and science. It's basically the fallacy of calculating the probability of a specific event after that event has already occurred and been observed.
Okay, give me a concrete example.
Think about winning the lottery. Before the draw, the probability of any specific combination of numbers coming up is astronomically small, right? Let's say 1 in 100 million.
Tiny odds.
Right. But after the numbers have been drawn, and you happen to be holding the one winning ticket, you don't then look at your ticket and conclude the lottery must have been rigged because the odds of your specific numbers coming up were so incredibly low. The improbability existed before the event happened. Certainty exists after it happened. Someone had to win, and their ticket, by definition, had that incredibly low a priori probability.
Okay, I see. So applying that to 3I Atlas,
Yeah.
we look at this incredibly complex object after we found it. We identify, say, 10 really unique characteristics. Its extreme age, that 16x CO2 ratio, the specific trajectory angles, the unique polarization curve, the nickel compound.
And then we multiply the low probabilities of each of those individual features together and calculate that the chance of all those specific features coinciding in one object is nearly zero.
Which sounds like proof of design. But the fallacy is...
The fallacy is that every object, especially complex natural objects like comets or galaxies or even individual humans, is unique in some combination of ways. If you start with any random object, carefully list 10 of its most unusual or specific characteristics, and then calculate the joint probability of that specific combination occurring, you'll almost always arrive at an incredibly small number. You can prove that almost anything is statistically impossible relative to the average.
So just because 3I Atlas has a unique combination of weird features doesn't in itself prove it was designed or artificial. It just proves it's unique.
Exactly. The consensus view cautions strongly against using this post hoc calculation, finding unique traits after the fact, and multiplying their low probabilities as sufficient proof for an extraordinary low probability origin like alien technology. It's seen as a misuse of statistics.
That's a very strong argument for maintaining scientific rigor and avoiding jumping to conclusions.
Yeah.
Yet, the proponent of the alien hypothesis, he keeps insisting that dismissing outliers like this risks missing something historic. And he often brings up the case of that other object, 2020 SO, as an example where the consensus was wrong.
Right, that's often presented as his kind of ace in the hole for keeping an open mind, a cautionary tale. 2020 SO was an object that was discovered temporarily orbiting Earth back in, well, 2020.
And initially, everyone thought it was just a small asteroid, right? A mini-moon captured by Earth's gravity.
Correct. The initial classification, the scientific consensus was pretty strong. Small, natural asteroid. But then, thankfully, astronomers performed more detailed analysis, specifically looking at its spectral signature, how it reflected sunlight at different wavelengths. And that revealed something shocking.
What did they find?
Its composition didn't match rock at all. It perfectly matched stainless steel.
Stainless steel. Meaning it was man-made.
Definitely man-made. It was quickly identified as the spent upper stage, the Centaur rocket booster from NASA's failed Surveyor 2 lunar landing mission, launched way back in 1966. It had been drifting in a solar orbit for decades and just happened to wander back near Earth.
So if astronomers had rigidly stuck to the it's probably just a rock or a cat on the terrace logic and hadn't done that extraspectral check,
they would have permanently misidentified a piece of old human space junk as a natural asteroid. His point is that sometimes the extraordinary hypothesis does turn out to be correct, even if it seems unlikely at first. And, he argues, the stakes for potentially misidentifying a genuine piece of non-human technology as just a weird rock are astronomically high. We can't afford to get that wrong.
This really highlights the central tension in this whole controversy, doesn't it? You have this highly credentialed, very public scientist arguing passionately for open-minded exploration, basically saying the potential payoff of finding non-terrestrial technology is so immense that we must consider it, even if the odds seem low.
Right. And then you have the critics, the majority of the community, arguing that repeatedly linking almost every new strange astronomical phenomenon. First it was Oumuamua, then maybe fast radio bursts, now Three-Eye Atlas to alien technology, without truly conclusive smoking gun evidence risks lowering scientific standards.
And potentially harming public trust.
That's a major concern, too. They feel it generates unnecessary public confusion, maybe even alarm, especially when these nuanced scientific debates get simplified or sensationalized in the media. Speculation is fine, they'd say, even essential in science, but it needs to be clearly presented as a very low probability hypothesis, not given undue weight. And to be fair, the scientist proposing the alien idea for Three Atlas himself usually frames it carefully, often stating he thinks the chance of it being artificial is low, but the potential consequences, if it is, are so high that it warrants serious investigation.
Which, unfortunately, brings us to the issue of misinformation and how these stories can spiral out of control. We saw those viral claims circulating online that planet defense protocols had been activated specifically because of Three-Eye Atlas, implying an imminent threat. What was the actual truth behind that story?
Yeah, that caused quite a stir. The reality was much more mundane, much more logistical, but actually quite important for the science itself. What happened was that the IAWN, that's the International Asteroid Warning Network.
Okay, that's a UN-affiliated group, right? Not just NASA.
Correct. It's a global collaboration of observatories and agencies coordinated under the UN. They activated a pre-planned observation exercise. Keyword, exercise.
They were basically running a drill, practicing their procedures. Why choose Three-Eye Atlas for their practice run?
They chose it precisely because its nature as an active comet makes it a really challenging object to track accurately. Unlike asteroids, which are usually just small, sharp points of light, comets have these big, fuzzy, extended comas, the cloud of gas and dust.
Which makes pinpointing the exact location of the solid nucleus inside much harder.
Exactly. It creates what astronomers call an astrometry challenge. Getting precise position measurements, which are absolutely critical if you want to predict an object's future path accurately, extremely difficult for fuzzy, active comets compared to point-like asteroids.
So IAWN selected Three-Eye Atlas simply as a difficult real-world test case to practice and refine their techniques for tracking these challenging fuzzy objects. It wasn't about an incoming alien invasion.
Not at all. It was a valuable logistical exercise to improve their core mission capability, which is accurately tracking all near-Earth objects, especially the difficult ones. It was chosen because it was a genuine technical challenge for observation and orbit prediction, not because it was perceived as an active maneuvering alien threat.
That's a really critical distinction. They were using its inherent difficulty as a training opportunity, not reacting to hostile intent.
It was purely a logistical challenge related to its cometary nature, not an existential one based on its origin or hypothetical purpose. Its general path was known, but its fuzziness made the high-precision tracking needed for long-term risk assessment much harder. Perfect for a drill.
Okay, so we have this fascinating clash. Compelling statistics hinting at design versus the powerful argument of natural abundance and the pitfalls of posterior probability. We have a scientific consensus favoring a natural, albeit extremely weird, comet, challenged by a prominent voice urging open-mindedness about outliers. But the beauty of this whole situation, the beauty of science really, is that this specific controversy isn't just philosophical. It's built around a single, concrete, testable prediction that should resolve the central argument relatively soon. Let's move to Section 4, the ultimate tests and future opportunities.
Absolutely. The entire premise of the technological hypothesis, especially the dark forest variant with its hidden maneuver, hinges critically on what happens around perihelion passage. The prediction is clear. If Three-Eye Atlas is indeed a design vessel intending to change its path stealthily,
it must execute that major, high-thrust, non-gravitational trajectory change, that reverse Oberth maneuver we discussed right around late October 2025, while it's hidden from our view behind the sun.
That's the core prediction. No maneuver, no hidden agenda, likely no artificial origin.
So how will astronomers actually verify whether that maneuver took place or not? We can't see it happen when it's behind the sun.
We don't need to see the maneuver itself. We just need to wait until the object emerges back into view from behind the sun, which will happen in the weeks following late October. We already have extremely precise measurements of its trajectory before it went into solar conjunction.
We know exactly where it should be going based on gravity.
Precisely. Based on Newtonian gravity, plus the small, already measured non-gravitational push, presumably from its natural outgassing. So as soon as it reappears, telescopes around the world will lock onto it and immediately measure its current position, velocity, and vector.
And compare it to the prediction.
Exactly. If 3I Lass emerges and is found to be continuing precisely along its expected hyperbolic path, the one governed purely by gravity and the previously observed gentle outgassing,
Then the alien technology hypothesis, especially the hidden maneuver part, is effectively falsified.
pretty much, yes. It would strongly suggest that no large, deliberate braking maneuver occurred while it was hidden. The case for it being a natural object, however strange, would become almost insurmountable.
But the other possibility, if, when it emerges in the coming weeks and months, our tracking reveals a significant new non-gravitational acceleration, a clear, undeniable deviation from the purely gravitational predicted trajectory.
Then the game changes entirely. If a major unexplained change in its path is detected after perihelion, the case for some form of intelligent control, some kind of propulsion system being activated, strengthens dramatically. That would be potentially paradigm-shifting evidence. The scientific world is quite literally holding its collective breath, waiting for that post-perihelion trajectory verification data.
It's a fascinating high-stakes test. But regardless of how that test turns out, whether it emerges on schedule or on a completely new path, we really need to emphasize that 3I Atlas, just by existing and visiting us, is an absolutely unparalleled scientific gift.
That's such a crucial point. Even if the final verdict is definitively 100% natural weird comet, its value to science is immense.
Because, as you said, it's potentially an 11 billion-year-old time capsule.
Exactly. Think about that age again, 11 billion years, and its apparent origin from the dense, chemically different region near the galactic center. It means this object carries physical, compositional information about the conditions in the very early universe, about how galaxies and perhaps the first planetary systems formed in a way that we could never access otherwise.
It's like a message in a bottle from the deep past in a distant, exotic place.
Precisely. We cannot physically travel the tens of thousands of light years to the galactic center to sample the material there. But this object, potentially formed in the supercold CO2 ice line of its own ancient, maybe metal-poor protoplanetary disk billions and billions of years ago, has traveled all the way to us.
And just by studying its composition, we're forced to revise everything we thought we knew.
Every single model we have. Models for comet formation, for the chemistry of protoplanetary disks, for galaxy dynamics, for the building blocks of planets. 3I Atlas shows us definitively that stellar formation processes elsewhere in the galaxy can produce fundamentally different outcomes, different chemical starting materials, than what we find in our own relatively water-rich Oort cloud here. This is a truly unique, maybe once-in-a-civilization opportunity to study the deep cosmos right here in our own backyard.
We know that the big guns, Hubble, and especially the James Webb Space Telescope, JWST, have already provided that critical compositional data, the CO2 dominance, the nickel tetracarbonyl. What's the timeline look like for future observations, maybe getting even closer looks?
Well, the object itself will continue through the solar system for a while. Its actual closest approach to Earth will happen a bit later, on December 19th, 2025.
How close will it get to us then?
Still pretty far, about 1.8 AU. That's almost twice the distance from the Earth to the Sun, so no collision risk or anything like that. But at that distance, it should become bright enough to be visible, even with relatively small, dedicated backyard telescopes for skilled amateur astronomers.
Which is great for getting lots of eyes on it, lots of tracking data.
Absolutely. It allows for broad participation and continuous monitoring. But perhaps the most exciting prospect for getting really detailed, close-up in situ data involves potentially repurposing an existing deep space asset. You mentioned the Juno diversion proposal earlier.
Yes. Tell us more about that. It sounds incredibly opportunistic.
It's a highly compelling idea, though certainly daring. It was actually put forward by the same scientist who's been prominently proposing the alien hypothesis. The concept leverages NASA's long-lived Juno probe.
Juno's been orbiting Jupiter for years, right? Studying its magnetic field, atmosphere.
Exactly. It arrived at Jupiter back in 2016 and has already far exceeded its original primary mission lifetime, which was planned for maybe 7 years. Its original planned fate was to eventually perform a controlled crash into Jupiter's atmosphere at the end of its mission.
Why crash it?
To avoid any remote possibility of it accidentally contaminating one of Jupiter's potentially habitable moons, like Europa, with Earth microbes if it ran out of fuel and drifted into an impact trajectory later. Standard planetary protection protocol.
Okay, so instead of letting it just die in Jupiter's clouds.
The proposal is to use the small amount of residual fuel that Juno likely still has on board to execute a carefully calculated diversion maneuver. This wouldn't be easy, but calculations suggest it might be possible to slightly alter Juno's orbit around Jupiter.
To do what?
To set it up for an extreme close flyby encounter with 3I Atlas in March 2026. That happens to be when 3I Atlas itself makes its closest approach to Jupiter on its way out of the solar system.
Whoa. So we could potentially send an existing probe already in the neighborhood to swoop right past this interstellar visitor. That would be incredible.
It would be a scientific triumph. Imagine capturing high-resolution images of the nucleus, directly sampling the gas and dust in the coma with Juno's instruments. Getting definitive, close-up data on its composition, its structure, its activity level, just months after its perihelion passage. It could potentially resolve the entire debate about its nature and fundamentally rewrite our understanding of interstellar objects and cosmic building blocks.
What are the main risks or challenges for that kind of mission?
The risks are primarily navigational and timing related. It involves a complex, last-minute course correction for a very old spacecraft, aiming it precisely at a fast-moving, fuzzy target based on potentially uncertain trajectory predictions for 3I Atlas itself, especially if it does perform unexpected maneuvers. And you'd have to make the decision very quickly based on the post-perihelion observations. But the potential scientific reward is just immense. It's a fantastic example of scientific opportunism, using what we already have in space to seize a unique, fleeting opportunity.
It really underscores just how significant this object is, whether we're dealing with, a colossal 11 billion-year-old chunk of cosmic dry ice that just happens to have nickel tetracarbonyl on it, or whether it's a highly advanced piece of technology deliberately masked as a comet. 3I Atlas has undeniably forced us to confront the limits of our current scientific models and assumptions.
Absolutely. The sheer number of simultaneous significant anomalies, the trajectory that seems too perfect, the industrial chemical signature, the unique polarization, the blue color, the rapid brightening, the large unexplained non-gravitational acceleration. It means we are still facing a profound scientific mystery no matter what. Even if the final verdict comes down firmly on the side of natural comet, it's a comet that is pushing our existing physics and chemistry models way past their breaking point. We have to learn something new from it.
So we really do stand at a critical scientific crossroads here. Let's try to synthesize the whole situation as we wrap up this deep dive. Where do things stand right now?
Well, you basically have these two competing, but importantly, data-driven perspectives. On one side, you have the consensus view, high probability of being natural, but also incredibly high scientific interest because it's so weird.
The sensible explanation.
Right. The object is a natural comet, and its extreme anomalies are simply revealing gaps or limitations in our current understanding of comet formation and behavior, especially for objects formed in vastly different environments or times. Our models need revision. This is the standard, low-risk scientific position strongly supported by the overwhelming relative abundance argument, the cat on the terrace theory. It's almost certainly just a very, very strange cat.
Okay, and on the other side?
On the other side, you have the low probability but potentially civilization-altering high-consequence technological hypothesis. This argument rests on what proponents see as a statistically impossible conjunction of anomalies. The orbital parameters suggesting deliberate design, the close planetary approaches, the perfectly timed clandestine maneuver window, all layered on top of physical and chemical signatures like the nickel compound and the unexplained acceleration that strongly defy easy or satisfying natural explanations right now.
Two very different interpretations of the same strange data points.
But the crucial point remains. The core difference between these two hypotheses, at least the version involving a hidden maneuver, is entirely testable. And that test, that verification, is imminent. It's happening right now as the object passes perihelion.
So the data itself will likely provide the answer soon.
Hopefully. If the object executes that major unexpected orbital change while behind the sun, the game changes completely. The artificial hypothesis gains enormous ground. If, however, it emerges from behind the sun, traveling exactly along its predicted gravity-dominated hyperbolic path, then the consensus view stands firm, and 3I Atlas simply remains the most complex, baffling natural anomaly astronomers have ever encountered. A fascinating puzzle, but likely not an alien one.
You know, what resonates with me most about this whole affair, beyond the fascinating science, is what this object, this visitor, reveals about us, about human nature when we look up at the sky.
How so?
It seems to embody our deeply ambivalent relationship with the cosmos. On the one hand, there's this powerful, almost universal human desire to find proof that we are not alone, right? To find connection, meaning maybe even companionship in the staggering vastness of space.
Yeah, the hope aspect.
Exactly. Yet at the exact same time, there's this profound, almost primal fear of what that contact might actually bring if it happens. It's the existential anxiety that's reflected so perfectly in that chilling concept you described, the dark forest, the fear of the unknown predator.
It taps into both our greatest hopes and our deepest fears simultaneously.
Absolutely. And the sheer rarity, the audacity, the extreme characteristics of 3I Atlas, whether it ultimately proves to be a technological artifact or just an 11-billion-year-old ball of exotic ice, it forces us to confront that fundamental duality within ourselves, the thrill of potential discovery versus the profound fear of exposure. Are we hoping to find neighbors, or are we terrified of attracting attention? Maybe both at once.
And this isn't a historical thought experiment. As you said, this story is unfolding right now in these late stages of 2025. The object is currently making its closest pass by the sun, hidden from our direct view. And scientists, observers around the world, are poised, waiting to take those critical measurements as it emerges over the next few weeks and months.
So the final provocative thought we want to leave you, the listener, with is this. Watch the skies. Follow the data. The verification of 3I Atlas's post-perihelion trajectory is the ultimate imminent test of this extraordinary hypothesis. By tracking the outcome of that trajectory measurement as the results come in, you can, in a sense, determine for yourself the fate of the alien technology claim versus the extremely weird comet explanation. The universe is about to show us its hand on this one.